All right, so we have that the amount in milligrams of a medicinal drug in the body T hours after it was injected is given by dt equals blah blah blah. See, before this injection, the amount of drug in the body was 0. For part 1AI, we need to write the initial dose of the drug. Now, there's a couple of keywords going around here. First of all, for T hours, it's after it was injected. See? And the keyword for part 1, part A, part I is initial dose of the drug. So initial makes us think of like the beginning, right? And so the initial dose of the drug is going to be as early as we can in our function. How is the earliest we can go in our function? Well, t has to be greater than or equal to 0. So that is 0, 1, 2, 3. I cannot go negatively in this case, ¿cierto? These negative values are not included because we are only looking at t greater than or equal to 0. So that being said, the lowest I can go is 0, right? So I'm going to plug in d with t equals 0 like this. Now notice, anything to the power of 0 is going to be 1. So this actually turns into 23 times 1. So 23 times 1 is going to equal simply 23. See, so the initial dose of the drug is 23, 23 what? Milligrams. So that is part 1, part A, part I. For part 1, part A, part double I, we have the percentage of the drug that leaves the body each hour. Okay, so here it gets a little bit more creative, right? So our function looks a little bit like this. And here it's more about being familiar with like how these functions work in the first place. See? And so what is affecting my initial dose, which is 23, ¿cierto? This 23 here. What is affecting my initial dose is this 0.85 right there, ¿cierto? And so 0.85 is taking away how much from 23? That is kind of like the question we're trying to answer. That is the most intuitive way I can put it, ¿cierto? And so what a lot of people do here is that they say, okay, the percentage of the drug that leaves the body each hour is the number right next to 23, so it's 85%. See? Now, there's a way to check this, ¿cierto? This is a mistake, and there's a very intuitive way to figure it out. So if 85% is what leaves each hour, after 1 hour, I should have very little dose left, ¿cierto? So let's see if that's actually true. We take this 23, we multiply it by 0.85, and we put it to the power of 1, ¿cierto? Because 1 hour has passed. Now, if effectively 85% leaves after 1 hour, I should end up with a really small number. However, I end up with a very big number. I end up with 19.55. So there's no way that I'm losing 85% per hour, ¿cierto? So actually what's going on here is that this 0.85 is taking away 15%. See? The best way I can explain it is that you should do 1 minus 0.85, and this is how much is being taken away, 0.15. 0.15 turned into a percent, multiplying by 100, ¿cierto? Will give you 15%. See? So that is like the intuitive way of understanding these functions. Now, finally, we need to calculate for part B, ¿cierto? The amount of drug remaining in the body 10 hours after the injection. So, the only trap here that they might throw at us is that this hours here isn't the same as this t here, ¿cierto? However, for this problem, this t here is equal to the amount of hours there, ¿cierto? So they're all hours, is what I'm trying to say. Sometimes the AB has it in days, other times in hours. They ask it in hours, they give it in days, and you're gonna have an eye for that, ¿cierto? In this case, we're all good to simply plug in. So for part 1b, we will simply plug in d10, ¿cierto? So our t is going to be equal to 10. We have 23 times 0.85 to the power of 10, right? And so that will give me, give me a second, that gives you 4.52811. See? Don't forget your units, we put milligrams. If you want to simplify it a little bit, you would leave it as 4.53 milligrams. Both answers work. So that is number 1.